Exponential and logarithmic equations. We'll begin with exponential equations and then we'll do some log equations. Solving them, that is. First thing, if you see an equation where the bases are the same, that means that the exponents have to be the same. So all we'll do is set the exponents equal to one another. Now, if we have different bases on each side of the equal sign, here's what we're going to do. First step is to isolate the exponential term. That means we want to get the term that has the exponent in the variable. The exponent is a variable. We're going to isolate that, which means we'll eliminate all numbers around it. And then there's two main ways to solve from there. Either we'll convert to a log form using the definition, or we'll take the natural log of both sides. We could easily take the log of both sides, log base 10, or common log, but we'll take the ln most times. Just depends. So let's solve a few of these. 2 to the x equals 30. Now the first thing I'm going to think about is there's no way I can rewrite 2 to some power and have that equal to 30. So that's what I'm going to do. I'm going to either convert this to a log, or I'm going to take the natural log of both sides. Either way is fine. You decide what method you want to use. Now, if you do use the definition, I'm going to actually do this one a couple of different ways, just so you know the difference. Then I may just stick with one way. If we want to use the definition, I'll write the word log down, and I'll start with the base, which is 2. And then I know that logs equal exponents, so that means that the log equals x, and then the 30 remains. And then from here, I'll use change of base to rewrite it. Change of base says I write log of 30 over log of 2 because the base goes on the bottom. Now for some systems, for some instructors, this is your answer. For others, it's not. They want you to type it in. So I'm going to take out my calculator and we're going to type it in carefully. So we're going to type in log 30, close parentheses, divided by log 2, and hit enter. If you round off, that's approximately 4.91. We'll go 2 decimal places. So that's one approach. I'm going to erase this and use the approach. Now, some people like the definition, and here's my thinking. Whenever in doubt, always use the definition, especially if you already know that. That should be one of the first things that you learn about logarithms. But if you want to learn something that's probably a little bit easier, and this is the method I'm going to use from now on, I'm going to take the natural log of both sides. Now when I do this, you're going to notice that the 2 to the x, the exponential term, is already isolated. So that means I can go ahead, and when I say take the natural log of both sides, that just means I'm going to write natural log in front of both of them, in front of both sides, just like that. And then I'm going to use one of my properties that says that this exponent can move out in front. So it comes out as x natural log of 2, x natural log of 2 equals natural log of 30. I need to slow down. And since this is multiplication and natural log of 2 is nothing but a number, or however you want to look at it, to isolate the x, I will divide both sides by the natural log of 2. These will cancel. And I'm left with natural log of 30 divided by natural log of 2. I already know what the answer should be, still on my calculator, so I'm going to type in natural log of 30. Not 31, I don't know where that came from. Natural log of 30 divided by natural log of 2. Now we do get the same answer. And the reason is because the change of base, it does not matter what the base is. You get the same answer. So we're done. So I think this way is probably easier, but just as a preference. But I'm going to use taking the natural log of both sides just to be consistent. That's what most books use, what most systems use, so that's what I'm going to use. Now let's do 27 to the x equals 5. No way can I make each of those to have the same base. So I'm just going to take the natural log of both sides, and I should have given myself some space. I need some space. So I'm just write natural log in front and move the exponent out in front. And I'm going to divide. Now some people, the natural log of 5 over natural log of 27 is the desired answer, so you'll be done. But if they want a decimal approximation, that's when you will take out your calculator and type it in. And be very careful to close that parentheses after that 5. We get about 0.488. Now how you round depends on what's being asked. Just to change it up, if you want to use the definition, we can. We'll start with the word log, and then the base of 7 equals the exponent, which is x. And if you want to use change of base, you can, or you really have to at this point. And then that's the final answer for some people, but to get the decimal approximation, those are squigglies. We'll just type in log of 4, or log of 7, I mean. What was I thinking? Log of 7 divided by log of 4. We get approximately 1.404. To the next one, just to show you it doesn't matter, I'm going to take the natural log of both sides. Now this one is not going to be as easy, so I might have to use some extra space. Now I'm going to move the exponent out in front, and I'm going to put that in parentheses. Now what I'm going to do, I'm going to divide both sides by the natural log of 8. Now depending on the system that you're using or your instructor, they may want a different type of answer. Hopefully they'll take this. Now I want to isolate the x, so I'm going to add 1 to both sides. So we get x equals natural log of 34 divided by natural log of 8 plus 1. Now they may want the answer to be slightly different. If they do, that's where you want to distribute the natural log of 8. And I'll probably come back and do that later. I'm going to go ahead and finish this one up. Let's do the approximation, because I don't know what your instructor wants, so I'm going to show you what they may want. So let's just type in natural log of 34 divided by natural log of 8. And keep in mind, this may be an acceptable answer for your instructor. I don't know who your instructor is. Then add 1. And you get about 2.696. Now I'm going to come over here and erase this and show you how else your instructor may want the answer. I don't know. But this just in case. If you want to fast forward through this, go ahead and fast forward through it. But you never know about your instructor. See this part right here? Your instructor may want this. They may want you to distribute the natural log of 8. So that would be natural log of 8. I'm going to put the x in front. Minus natural log of 8 times 1 is natural log of 8 equals natural log of 34. Then they may want you to add natural log of 8. I want to erase that. It's bothering me a little bit. They may want you to add natural log of 8, because you should. And you end up with x natural log of 8 equals natural log of 34 plus natural log of 8. And the last step will be to divide natural log of 8. So this may be the answer that they're looking for. Once again, I don't know. All this will be the answer. And you usually could have done that with this by writing that 1 is natural log of 8 over natural log of 8. But people don't really like fractions too much, so you may want to approach it that way. Now this may have been unnecessary. I don't know who your instructor is. So just be aware. You're hoping that they want you to give the decimal value, and if they do, then this is a good way to do it. Now let's do this example. When you do this one, you'll notice that we already have the same base. Both are e. So that means that these e's like cancel out, and you're just solving 2x equals 3. Divide both sides by 2. And you get x equals 3/2. These are kinds that you like. Well, hopefully you'll recognize that. And if you don't, take the natural log of both sides. You'll still get the same thing. Now this one, there's a situation here because I have a number in the way. The 30 is in the way. So what I'm going to do is get rid of it by dividing both sides by 30. I'm not going to use a decimal. I'm going to keep it as this. Don't want a decimal yet. Now I'm going to take the natural log of both sides. Natural log of e to the x equals the natural log of 129 over 30. This is by far the best way to do this one. But when you have e's, definitely take the natural log of both sides. The reason being is because the natural log of e to the x is one of the properties that you should know, and that equals a regular x. And the right side, I'm just going to keep it as it is. Now I could rewrite it, but there really is no reason to. I could write it as natural log of 129 minus natural log of 30. Your instructor may or may not want you to. But what I can do though is you find the decimal approximation. So natural log of 129 divided by 30. That's approximately 1.457. Now this last one is not going to be any fun at all. Just a warning. This will not be any fun. What I'm going to do, I take a breath. It's going to take a lot of work. I'm going to take the natural log of both sides. That just means I'm going to write a natural log in front of both sides. Then I'm going to move the exponents out in front. I'm going to put that x plus 8 inside parentheses. And then I am going to distribute this natural log of 9. So x times natural log of 9 is x natural log of 9 plus 8 natural log of 9. Now, here's what's going on. I have two x terms. Now, natural log of 4 and natural log of 9 are just plain old numbers. They're actually ugly decimals that you can't write down. That's why we have this natural log symbol. And this 8 natural log of 9 is nothing but a number also. So what I'm going to do is I'm going to subtract off x natural log of 9. And I'm going to end up with this. 2x natural log of 4 minus x natural log of 9 equals 8 natural log of 9. Now what I'm going to have to do, I could use decimals, but your instructor may want exact answers, so I'm going to have to factor out the x from these two terms because they both have an x in common. So when I take out the x, or factor it out, I'm bringing the x out in front. When I divide each of these terms by the x, we'll end up with 2 natural log of 4 minus natural log of 9. And then the right side doesn't do anything except stays as it is. This is the only way, if you're asked to solve it in exact terms, this is the way you want to approach it, and this is the way you want to get the x by itself. Factor. There may be other ways, but probably not easier. And so, when you get to this step, after you're factoring, you want to divide both sides by 2 natural log of 4 minus natural log of 9. Hopefully you won't see this kind of a problem anywhere, but you could. X's cancel, and this is your final answer. That's your exact answer. Now if your instructor wants you to have the decimal approximation of it, let's see if we can type it in correctly. I'm going to just be safe. You do parentheses, 8 natural log of 9, close, and close again. These two parentheses are for the whole numerator, divided by, open parentheses. This first parentheses is for the whole denominator, so let's type in 2 natural log of 4, close that one, that's just for the 4, minus natural log of 9, close, that's for the 9, and then close again for the parentheses at the beginning of the denominator. Hit enter, and we get that value, about 30.551, and we're done. Log equations. Now to solve log equations, if you have two sides that are equal and the logs are isolated on each side with the same base, that means that the outputs, or the x and the y, have to be the same also. So keep that in mind. Now otherwise, we're going to isolate as a single log if there's more than one log on the same side, and then we're going to use the definition to convert to exponential form. So let's do some examples. Let's do this first one. 2 plus the natural log of x equals negative 1. Now, by the way, this third thing we should always do is check our answer. This is the big deal on this one, on these log equations. So, for question A, 2 plus natural log of x equals negative 1, we're going to isolate the natural log of x first. That 2 is in the way, so we're going to subtract 2 from both sides. And we get natural log of x equals negative 3. And now natural log of x is the same as log base e of x equals negative 3, which means we can convert that to exponential form by starting with the base, which is e, raise that to negative 3 power, and that equals x. Remember the definition. Logs equal exponents. Since negative 3 equals the log, that's our exponent on the base e. Now, if we want, and that's the exact answer, and that is a final answer for a lot of people, but if you want a decimal approximation, we can just type in e to the negative 3 power. Turn on your calculator. That always helps. Yes, it does. And you can write down 0 or 0.05 as approximation. Now, let's do this next one. Natural log of x plus 7 equals natural log of 4x plus 5. Now, before I do anything else, you just need to be aware that this is a positive value. So the only thing when I say check, the only thing we're checking is to make sure we don't take the natural log of 0 or of a negative number, because you can't. Or log of any 0 or negative number, you can't do it. So that's what we're checking. Now B part, if you notice, both sides already have the natural logs. And for both sides to be equal, that can only mean that x plus 7 must equal 4x plus 5. In a certain sense, you can think of it as the natural logs canceling out. And now we're going to solve like we normally would. I'm subtracting the x, and hopefully you know how to do this. And if you don't, not going to say anything. I want to, but I'm not going to. And then subtract 5. We get 2 equals 3x, and divide by 3. And we're done. X equals 2/3. Now, let's do question C. I'm going to erase this a little bit so it's not a distraction. What you're going to notice with this one is that we have log base 2 twice on the same side, separated by an addition sign. Well, what that means is we can combine these two logs together as a single log since they're being added. And we can do that if we multiply x and x plus 2. It's one of the properties that you need to know. Now, I'm going to go ahead and clean up what's inside the brackets and distribute the x. And we get x squared plus 2x. And then, since it's in log form, I can now convert it to exponential form by starting with the 2. Which is the base, and logs equal exponent, which is 3. And that equals what's left over, x squared plus 2x. And now it's an algebra problem. And let's hope that you remember how to do these. So 2 cubed is 8. Since it has x squared, that means it's quadratic. I need it equal to 0, so I'm going to subtract 8 from both sides. And I'm going to look down here for a second. So there's something else. I'm going to move it up here so it won't be in the way. This thing is really sensitive. So now we have 0, because 8 minus 8 is 0, equals x squared plus 2x minus 8. Now we have to solve this. Now, depending on the person, will depend which process you use. I'm going to use factoring because I know how to factor. And I can use a quadratic formula, and I can use something else, which I'll show you. But I'm going to factor. I'm using algebra. So what times what is x squared? X and x. What times what is negative 8? That equals plus 2. Sounds like it's a plus 4 minus 2 to me. Check it. X squared minus 2x plus 4x is plus 2x and minus 8. Set each factor equal to 0. Solve for x. Subtract 4 from both sides. had 2. X equals -4 or x equals 2. Check. If I take a -4 and substitute for the x, I'll be taking the log of a negative number. I can't take the log of a negative number, no matter what the base is. Well, hopefully I'll type it in. Error. It's outside the domain. I can't do it. So what that means is that 4 won't work. But the positive, if I were to substitute in here, I get log of 2. If I substitute in here, I get log 2 plus 2, which is log of 4. I can find those because they're positive values. So this x equals 2 is my final answer. Don't automatically assume that the negative answer is always the one that checks out or cancels out. Sometimes it's the one that does check out. It just depends on the equation. So be aware. Let's do one more of these. Now when you look at this one, by the way, sometimes you may have a problem where both of them fail or don't check out. So rare, but it can happen. Let's do this one. Notice we have, these are all log base 10 because none of them have a base that can be seen. They're not ln, so it's log base 10. You'll notice these two logs are on the same side, connected by subtraction, which means we can combine those with division. And the right side, I'll just leave it as it is. It's a single log already over there. Now this problem, you'll notice we have a log equals a log. They're the same. For both sides to be equal, that can only mean that what's inside the parentheses or what's after the log have to be equal. In a sense, they cancel out. The logs do, in a sense. So now we're going to solve this. Now, depending on you and what your algebra skills are, it depends on how you will solve this. What are we going to do? I think for most people, the easiest way to think of it is put that over 1 and crisscross, cross multiply. 5x times 1 is 5x equals 3 times x minus 7. I'm going to write it all out, not leaving out a single step. This may be the easiest approach. So we have 5x equals 3x, and 3 times 7 is -21, really. Subtract 3x. We get 2x equals -21. And divide both sides by 2. And we get x equals -21 or -10.5. Let's just use -21 halves. I mean, I said the halves just then, but -21 halves is the final answer, we think. Keep in mind the answer was a negative. If you take a negative number, times it by a positive 5, you're going to get a negative number back. Can we take the log of a negative number? And that's all we're checking, by the way. And we can't. Furthermore, if we put over here a negative number minus some other number, still is really negative. This doesn't check out. There's nothing else to check. This problem is a no solution problem. So that's why you have to always make sure to check your final answer when you're solving equations with logs in them. They don't always check out because you might be taking the log of a negative number, which you can't do. So always remember to do that.